I'm going to show you how to balance equations now, okay? So I'm just going to take random equations from the whole entire unit. So the first one I'm going to look at is the periodic table. So the first one in group 1, so think about group 1 reacting with water. So for example, if you had sodium plus water, it will go to give you sodium hydroxide, NaOH, plus H2. Now, if you had to put that to your simple equation, remember, in the foundation papers, they tend to ask you the word equation, so be very careful if they ask you for symbol or word. So this would be sodium plus water goes to give you sodium hydroxide plus hydrogen. Now, if you're balancing this out, you look to see what way is easier to get you a multiple of 2. That's my wee trick for doing it. So if we can see here, we've got 1 hydrogen there and 2 here. This side we have 2, so that's an even number, whereas over here we've got 3. How can we make this into an even number? Put a 2 in front of the NaOH. Now what we need to do is then put 2 sodium, because you now have 2 sodium there, and we also need 2 oxygen, and again that balances out our hydrogens. The exact same works for any of the rest of the group 1 reacting in water. For example, let's say you had lithium plus water. Lithium plus water gives lithium hydroxide plus hydrogen. And again, balancing out 2, 2 and 2. Remember, if they ask you what the test for hydrogen is, the test for hydrogen is a lighted splint burns with a squeaky pop. So the test for hydrogen gas is lighted splint burns with a squeaky pop. That's 2 marks. Next topic I'm going to look at is still a periodic table, but it's to do with group 7. It's known as the displacement reactions. So if you're asked anything to do with displacement reactions, it's to do with group 7. Now remember the way to describe it. So displacement is whenever the more reactive element displaces the less reactive element. And again, this tends to be in relation to group 7. Now, what we know is, first of all, you've got group 7, you've got fluorine, chlorine, bromine, iodine, and then arsenic. Remember, when these elements are by themselves, they're normally diatomic. So diatomic is 2 elements covalently bonded together in a molecule. Make sure you use that last statement, in a molecule. If they ask you what a covalent bond is, it's just a shared pair of electrons. If we look here, fluorine is the most reactive, and arsenic is the least reactive. Okay? The reason being is that remember, if you're in group 7, you're trying to gain an electron, so there is less pull as you go down the group from the positive nucleus to get that electron in. Whereas fluorine, you've only got 1 shell to get out to get another electron in, so there's more pull from the positive nucleus to get that electron. Now, if we look here, I'm going to just pick a couple of them out here. So say, for example, you had chlorine plus potassium iodide. What that would give me is the iodine will be kicked out because it's the weaker of them. The chlorine will take its place, so we'll end up potassium chloride plus iodine. The reason why it's Cl2 and I2 is because they're diatomic, they can't be by themselves, remember. You never put a wee 2 down here just because you think it balances things out. If you were doing these like anything else with equations like potassium iodide, K plus, I minus, swap and drop, they both cancel each other out. It's 1 and 1, or it just means you've got one of each of them. So it's potassium iodide, okay? Now if you're trying to balance it out, you just look, you've got 2 chlorine, so you put 2 there, 2 iodine, and that balances out your potassiums as well. Same thing if we go for bromine. So say we've got bromine plus potassium iodide. We'll change potassium, we'll go with sodium instead here. Sodium iodide, it'll go to give me sodium bromide plus iodine, because remember, iodine's still the least reactive. Alright, now balance it out again, put 2 and 2. Next thing we will be asked here is like your acid and bases topic, okay? So just going through some of those. So acid plus bases. This here is, remember, the first one I'm going to look at is a neutralization reaction, okay? So there's loads of different types of reactions this here, but we're just going to go through a few of them. So say, for example, you get an acid plus a base. Remember, a base is just a soluble alkali. acid plus a base gives you a salt plus hydrogen. Don't know why I did like that. So hydrogen, again, ignore that. It's plus water. So acid plus base gives salt and water. So for example, your three acids, just to top us off here, it starts off here, you've got HCl, H2SO4, and you've got HNO3. You need to know them off by heart, non-negotiables, okay? So we'll start with the first one, HCl. So say hydrochloric acid plus potassium hydroxide. To get your salt, you take the start of the metal and the ending of the acid to make your salt up. So this one will be called potassium chloride plus water. Now, if I'm just double checking myself here, I'm going to double check my formula for this and my formula for this one here. So start off with K plus, OH minus, that represents 1 down here, 1 there, so they're both okay. Next one, potassium chloride, K plus, Cl minus, 1 and 1, so they're both dead on as well. This here, remember as I said to you, is called your neutralization reaction. Alright, so this is neutralization reaction. If they ask you for the ionic equation for this one, you will literally simply write down H plus OH minus goes to give you H2O. If they ask for state symbols, aqueous, liquid. Alright. All balanced, so no need to change anything there. Next one I'm going to go for is an acid plus a metal. Again, as per usual, it gives you out your salt, but in this case, it gives you out hydrogen. Now, guess try another one. So say we've got H2SO4 plus magnesium. It could be any metal at all. It gives me the salt now, so the salt, remember, you take your metal name and the ending of the acid, which is SO4, plus your hydrogen. If I look at this, it's already balanced out, so I have no call to change anything. Now again, just double check my MgSO4, Mg is 2 plus, SO4 2 minus is the back of your periodic table. You're only worried about the charges, so that's 2 there, 2. When you swap and drop them, they cancel out, so you just need one and one of them. Alright, that's dead on. Next one we go on to is your acid plus your metal carbonate. So the carbonate could also be hydrogen carbonate. So it could be a metal hydrogen carbonate. Again, both of those are found on the back of your periodic table for you. It'll also give you a salt plus water, but the extra thing now it gives off is carbon dioxide. And again, they could ask you the test for carbon dioxide gas, bubble through lime water, and it goes from colourless to a milky solution. We're going to try an equation now for this one. So say for example your acid now is HNO3 plus we'll go with potassium K2CO3. That will go to give me potassium nitrate plus water plus carbon dioxide. Now, if we want to balance this again, do the same thing. Try and look for something that's easy to balance for yourself. So I look here, potassiums, 2 potassiums there. I'm simply going to put a 2 in front of this. And then I look again, now I put 2 nitrates. So I'm going to go over here and put 2 nitrates over here. Trial and error and check. So now I've got 2 hydrogens, 2 hydrogens. I've got 2 nitrates, 2 nitrates. Then I also have 2 potassium, 2 potassium, 1 carbon, 1 carbon, 3 oxygens, so that's 1, 2, 3. Okay, so again, balanced. Look for something that's easy to do. Next one we're going to go on to is your half equations. So if they ask you how a chloride ion is formed, so they'll say to you a chloride ion is formed from a chlorine atom. Just make sure you read the questions, okay? Give the half equation for this. So you started off with your chlorine atom. Remember, they're diatomic, so they always have to exist at 2. Leave a space, draw your arrow, and it forms into your chlorine ion. Look at your periodic table. It's in group 7, so it's got a valency of minus. Okay, so it needs to gain an electron. Because remember, if you gain an electron, you become more negative. If we look here, to go from a chlorine atom to a chlorine ion, as I said to you, you gain electrons. So what you're going to do is plus your electron. Because we've got 2 chlorine, we need 2 E minus, and we need 2 Cls there. The next thing they could ask you to do is an ionic equation. Now, ionic equation, what you could do here, for example, is copper sulfate plus magnesium, and they'll tell you the rest of this goes into magnesium sulfate plus copper. Okay, this here also is known as displacement reaction because the more reactive metal is displaced, the less reactive metal. Now, what we look at here is, in this type of question, is look to see what has changed bonding, okay? Or even changed like state, so it's been from a solid to an aqueous solution or a liquid. So if we look over here, copper was bonded, it's now not bonded. Magnesium was not bonded here, now it's bonded. So these are the ones I'm worried about. The sulfate is known as your spectator ion, so it's not going to be part of the ionic equation. So when we do this here, we look at copper. So copper, it was in the bond, so it has a 2 plus charge, plus your magnesium, just your solid metal. Now magnesium's in a bond now, so it'll also end up with this charge, Mg2 plus your copper. Now if it's not in a bond in the normal equation, it'll stay by itself in the ionic. If it's in a bond in the equation, the normal equation, then yes, whenever you will have to put a charge into it. And that is your ionic equations.